we are actually, when I'm looking at quizzing us on this Friday for the first part of chapter 13, with the right triangle trig and law of sines, law of cosines. Last year, I did that on March 6th, so we're like right in that same week frame-ish in that neighborhood, so won't be a big deal. What I'm looking at today is I'm going to go through the law of cosine stuff. We'll probably get a couple of those examples real fast, and then I'm going to go and we'll probably start a couple of word problems as well, because I want to work through word problems for most of the day today and tomorrow especially, and then that way we can go back and do all the regular right triangle trig jump through Thursday. Yes, sir. I just that. I just grabbed that worksheet. I figured that it was just the same. This is all the same stuff. That one actually. Excuse me. And go from there. You guys remember what the law of cosines when we use that? you use it when law of sines doesn't work. Yeah, pretty much. That's pretty much the easiest way to think about it. Remember, you use law of sines if you have an angle and a side opposite. If you don't have that, you have to use the law of cosines. Okay. Bless you. So they say that law of cosines a lot of times is with the side angle side or side side side. So those are the two cases. Those are the two cases of the law of cosines that we use. And remember, law of cosines is that weird setup that has 3 different versions to it, and you really only need to know one of them. And again, I'm not going to make you memorize these formulas. I'll put them on there for us. Law of sines, law of cosines, those are generally formulas that are always given. I put them on the final. I put them on a formula sheet for that as well, so you don't have to worry about that. I didn't hear. No, what's that? What do you mean? Like law of sines or law of cosines? No, that's up to you. You have to know which one's which. I mean, it's really easy to tell which one's. I mean, law of sines is that ratio one. Law of cosines just looks really weird. Okay. Law of cosines is that weird scenario. And what's happening here with a lot of this is, before you get too much in here, when you have your triangle, the way that law of cosines works, excuse me, is that it has a relationship between a side to its angle. And when you work through them, the way that they write it out, if I say that I'm going to work with little a squared will equal b squared plus c squared. Make sure I write this out correctly. That's when you start these things. And you can rotate the letters all the way through. You can have b squared equals a squared plus c squared. C squared equals a squared plus b squared. And then what I want you guys, it looks similar to the pattern right there, but watch what happens at the tail end of it. What you have here is, in this case, we have b and c. So you subtract 2 times b, c. And then what side did we have on the other side of the equal sign? A. So then we multiply that times the cosine of angle A. So the lettering just repeats itself on a rotational basis. It looks really, really, really weird. This would be 2ac cosine of big B. It looks really, really weird as you write it out, but as you get going through it, you're always talking about you're wanting to set up an angle and its side opposite. You're trying to get to that relationship. And by using sides or using law of cosines, it gets you to that. Law of cosines, like I said, is weird, but as you get into it, you only have to use it once. As soon as you use the law of cosine one time, if you have a side angle side scenario, then you will automatically have an angle and a side opposite. If you have side, 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 if you use cosine, law of cosines to find an angle, then you will automatically have an angle and a side opposite, which drops you back to law of sines, which is quick. Okay? I put a little kind of reminder, and we've kind of talked about this a little bit here or there. Remember when you're dealing with your angles and your sides, your largest angle will always be across the longest side length, medium angle, medium side length, short side length, and so on. That comes into play pretty regularly with law of cosines, especially when you're working with the side case. I don't know if they talked about that last year with that. And I'll show you here why we do that. It kind of allows you, if you set it up a certain way, it allows you not to worry about the ambiguous case of the law of sines. Doesn't mean it doesn't always happen, but a lot of times it kind of helps you not have to worry. Okay? So yes, it is possible you could have the ambiguous case of the law of sines within a law of cosines problem. Yeah, it's awesome. It's great. No, only a smidge, not a lot, a smidge. I think this year we might not focus so much on the ambiguous with the cosine. I might work more with the word problems. Because those are fun. Because you can draw pictures and do stupid things. And it's kind of like sharks. Yeah, they got sharks. I actually have another shark problem. Scuba divers and sharks. Yeah. I will later. It's great. I get so excited about word problems because I'm an idiot. Anyway. Let's take a look at how this works. I'll write out. All right. Again, what do you think the very first thing I want to do is? I want to draw a picture right away. Little a is 12, little c is 16, and b is 38. Exactly. Now, when you get into this, we do not have an angle and its side opposite, which means it's forcing us to find one. This one is forcing us to find what first, an angle or a side, do you think? A side. It's making us find a side. The reason why I want to find a side is because if you take a look, I have the angle at 38, so I want to figure out what little b is. Okay? I'm going to set up and solve for little b first. So I'm going to write down the formula. What's that? We do. I got angle 38. I got 38 degrees at angle b. Okay? So I'm going to write out the formula in terms of b. And then I fill in the blanks. Did I have to isolate a variable here? No. This is just plug and chug. Right? Let me, so we got to take a picture in degree mode, otherwise bad things happen. What's that? Nice. What's a mistake? Oh, thank you. I was looking at it. Thank you. 16, 12 cosine 38. I'm getting b squared equals 97.40. Now what do I do to that to get b? Second square root of my answer, and I get 9.87. So now, the next step I'm going to do is I'm going to find the next, of the other two angles that we have, I want to find the larger of the two. Always go to the larger of the two angles next, which means which angle should I find? Good. Right. I have an angle and its side opposite, so now I have to use law of sines to get the angle C. So the sine of 38 is to 9.87 as the sine C is to 16. And that's the short, that's the easy scenario. You don't have to, we just move the 16 over. So I get 16 sine 38 divided by 9.87, second side of my answer, and I get 8641. Okay. Now, I had just found my second angle in a law of science problem, so what should I check? Check the supplement. Now, Carl, that's what you just said on yesterday, the whole check the supplement thing. So you have 180, subtract the 8641. I get 93. And I add back in the 38. I have room for a second triangle, don't I? So it is, you can't get a third triangle, so don't worry about that. So there is a slim possibility that you could get a secondary triangle, which then it just falls on what you did yesterday. Oh, I looked at a 1 I think, but yeah, it would still be. I was looking at the 38. I was getting the. I knew the answer was a 1 at the end, and I wrote 1 because I hit the button on the calculator, so I knew there was going to be space for it. So you have, in this case now, let's see, we have A, B, and C. 38. This was 9.87. This was the original. This is the original one. I'm doing that one first. So 180 subtract the 38, subtract the 8641. And then I do the same thing. Was it 12, 16. There you go. The first side B you get, all you have to do is, the only recalculation we did was the supplement and then subtract out. Because if you look at your sides and angles, small, small, medium, medium, large, large. Oh, I see. But in this case, we had to use that 987 because that's what we had to find to get us going. And we go from there. It's kind of ugly, but it's not like it's horrible. Let's try the other version of this. When you have the three sides. All right. So this one here is your side case. So let's see, 8, 18, and 13. And the easiest thing to remember here, excuse me, easiest thing to remember here is to always get the largest angle first. Always. If you start messing around with the smaller stuff, going with the smaller angles or the medium-sized one, you could wind up with just a lot of weirdness happening. It is always the best way to find these, and it's usually taught that way. Go with the largest angle first. Which of the angles should you find here? B. Good. So again, we'll write out that setup for the law of cosines in terms of B. Bless you. Okay, we fill in our blanks. So we have what? 18 squared is 8 squared plus 13 squared minus 2, 8, 13. Okay. Now, this just looks weird. You're trying to solve for B. What I want you to do is think of it this way. As you start putting it together, when you have to find an angle, take a minute and rewrite it as 2 different steps. It will alleviate a lot of screw-ups. What I mean is, I'm going to type right in, what is 18 squared? 324. What is 8 squared plus 13 squared? What is 2 times 8 times 13? Now, all of that is the exact same problem as this. That's the same problem. It's the exact same problem. Exactly. The concept between solving it is the exact same. Okay? If you were going to solve 12 equals 4 minus 2x, what would you do first? Subtract 4 and then divide by negative 2, right? Well, that means what am I going to do here? I got 91 equals negative 208 cosine of B. I guarantee 20% of you will forget that that negative is there. It happens. So we take 91 divided by negative 208, and I get some decimal. That decimal equals the cosine of angle B, which means what do I have to press then to get the angle? The inverse. Second cosine of my angle, and I bet you it's obtuse. And why do you think it's obtuse? It's the largest, but remember, where do obtuse angles wind up? In the second quadrant. And what was positive and what was negative? Remember, it was negative, positive. Cosine is negative in the second quadrant. Trig is trigged. So I get 115.94. Okay. Do I now have an angle and its side opposite? Yes. And then I just use law of sines on there. Should we just make it a rule for this year that we don't have to worry about ambiguous with cosines? Okay. I think we're okay with that. I will only give you it's not that it couldn't happen, but I think with the law of cosines, there's so much other stuff going on. I think it's okay just excuse me, to go ahead and say that if you have to use law of cosines, I won't require that you check for the ambiguous case. Law of sines, on the other hand, straight out of the way, you have to check. Is that fair? All right. What does that mean? And then, do I need to finish this out? Or Try another one like that. We'll get there. We might get a couple. I don't know. Playing it by ear. Take a minute and solve the whole triangle. Go through the whole thing, please. Solve the whole triangle. Sorry to make you feel bad. Did you guys find angle B next, I'm hoping? Good. $49.46. You okay with $49.46?
Yes.
And then lastly, yes. It forces you not to have to worry about it. And then 22.33. Hooray! Look outside. What?
You would just take forever. Try to be what I did. Am I Caleb?
Oh, that's fine. It's okay. No. I didn't recognize that at first. I should have noticed that. And that's why you were getting an domain there, because the biggest angle can't be across from the smaller side. All right, let's try this. Oh, that was the wrong sheet. Oh, there they are. Try one of the ones. Put them down.
I still have one session on this one.
I have two left. I only have one left. I have to, like, Caleb told me a thing. Now I have to do it. I just lost it. I don't know. What are we talking about?
Guys.
can draw it.
I apologize for all of the words. I did not have a chance to make a copy of a couple of these real quick today. No, because you probably should draw a picture that way you know what it looks like. Oh, it doesn't matter. Two scuba divers are 20 feet apart below the surface of the water. They see a shark below them. The angle of depression from one of them is 47 degrees and 40 degrees from the other. How far away from the shark is each of them? Because it was being personal.
Okay.
Why didn't you tell us how to
That's why they don't use those calculators.
Why does it have this?
And there's probably physics stuff in there too. All right, so here's what we've got. We have to understand what it looks like. We have to know how to draw them through and go from there. So the easiest thing to do is we know we have two scuba divers. And how far apart are they? 20 feet, okay? Angle of depression. Angle of depression, remember, is line of sight looking down. So if there's a shark in the water, AIDS in the water.
What is that?
It has bloody teeth. Sharky McSharkface. Whatever. Anyway, so guys, angle of depression, line of sight looking down. From one person, it was what? 47 degrees. From the other one, it was 40 degrees. You need to figure out how far are the two people from the sharks. What do you have? What are you going to use here to get that to work? Are you going to have to use law of sines or law of cosines? Law of sines. Why do you have to use law of sines? You can get that other angle and work your way out of it. Okay. And that's the idea. A lot of times when you have these word problems, it's not that it's really horribly difficult. It's the idea of what does it look like and how do you go from there. So first we're going to find out what angle that the shark is. So 180. Was it 93? Yeah. So so we have the sine of 93 is 220. Sine of 47 is we'll call that A, and we'll do the other one in. Chalk in the water. Each in the water. We should. Yeah, so I've got one person over here that's 14.65 feet away. It's a lot closer than I'd want to be to a shark. The other guy's closer, so we'll call him shark bait. Woo-ha-ha.
But it's huge, guys. Huge. Yeah.
Oh, I forgot. There's one other thing I need to show you.
I don't have it.
Sorry, there's this thing called Huron's formula. It's how you find side. It's how you find the area of a triangle if you have side, side, side. Actually, it's stupid. Don't ever use it. Use law of cosines to find the side angle side, and then just use the first one that I showed you. No. No. So. Yeah, I would. I would do that because in order to do that, I would ask that you, whenever you use law of cosines, you're always going to, when you have three sides, you're always going to find the largest angle. And then that will give you a side angle side case. And it's a lot faster to do it that way than to figure out all this stuff. This is a pain in the butt. It's stupid. No offense. There's nothing wrong with Heron. I think he was a cool guy. But I would never use this because it takes too long. I would just use law of cosines once, get the largest angle, then you had that side angle side. Remember we did that side angle side, it was 1/2, there was a side, and then the sine of the angle. I would do it that way. Okay? Don't ever use this formula, it's awful. Okay? Anyway.
You're gonna make us find the area when you have
No.
So the question is like finding a linear because that's it.
Alright, we'll go out from there tomorrow. Okay. Shouldn't be so bad.
I got stuck in that act for like 15 minutes.
Those first four, the first three, they are law of sines or law of cosines. It says solve the triangle. You have to make the decision of which method to use. It shouldn't be so bad. All right? I got a whole bunch of word problems we'll do tomorrow. Good times. They're fun. I really enjoy them. Yeah. I looked and I did it this morning. Should be.